Hello and welcome. In this video we are going to be talking about substitution and how equations allow us to substitute. And in particular I want to focus on functions and limits and think about what are the things that we're saying are equivalent at various steps of evaluating either a function value or simplifying a formula or calculating a limit. So consider this example where I have a function f of x. It's equal to x squared minus 5x. And so when I think about evaluation of a function, what I really want to think about is that I'm substituting in place of that variable x a value. So if I said f of 2, everywhere that 2 appears in the formula, I change the x. Everywhere x appears in the formula, I change the x to a 2. So f of 2 would be 2 squared minus 5 times 2. And so I want to visualize this in this presentation of actually thinking about all of those x's as being connected cards. So I've got a card x, they're connected, and every time I change the x, it turns over. So here I've got this example, and if I want to say, for example, talk about f evaluated at x plus 1, then everywhere I've got the x, all of the x's in this equation change to x plus 1. And so I've got these, I'm thinking here of these boxes as sides of a card. So on the left, I've got the front of a card. On the back, I've got the back of a card. So these are interchangeable. So I want to illustrate how I might use this in simplifying a formula. So for the same function, f of x equals x squared minus 5x, I want to simplify f of x plus 1 minus f of x minus 1. And so I've got one formula, so I'm representing that as a single card. And inside of this, I have two pieces to the formula. I've got f of x plus 1 and f of x minus 1. So I want to think about those two pieces as their own individual cards within a card, a formula within a formula. And when I think about f of x plus 1, if I think about what's on the back of that card, well, the back of that card is x plus 1 squared minus 5 times x plus 1. And f of x minus 1 is its own placard, its own card. It has a formula. And so if I turn that card over, in the rule for f of x, instead of changing x to x plus 1, I'm going to change all of those boxes. I'm going to put in them x minus 1. So now I have these two formulas. Okay. Now within these formulas, I have additional formulas now, right? I've got x plus 1 is squared, right? That's a piece of my formula. And if I think about, well, simplifying means rewriting this in a different way. X plus 1 squared, if I think about what that means, it's x plus 1 times x plus 1. So I could imagine replacing x plus 1 squared with this new formula. And I know a rule for this, right? I know how to expand this. Sometimes we say FOIL or distribute this all out. So if I think about x times x, that's the first term, it's x squared. First times the last term, that's the outside terms. X times 1 is x. Inside terms is 1 times x. And 1 times 1 is 1. I can think now of this as being rewritten as x squared plus 2x plus 1. And so this x squared plus 2x plus 1 can replace the x plus 1 squared. And each of those blocks, right, 5 times x plus 1 I can replace with a formula. X minus 1 squared I can replace with a formula. And I can do this over and over. Now, when I'm doing algebra on a paper, I'm not literally turning cards over, although it'd be kind of cool if I could. Instead, what we're doing is we're writing equations. And every time I write an equation, I'm saying f of x plus 1 minus f of x minus 1 equals a new formula. I want to think about, I'm turning cards over, right? F of x plus 1, I've turned that card over, and I've replaced it with this expanded formula of x plus 1 squared minus 5 times x plus 1. And f of x minus 1, I've replaced it by its formula. So now within those blocks, I can imagine those 4 separate pieces, I could expand them out, right? And now if I simplify these inside, the block on the left, I've got an x squared. I've got 2x minus 5x, that's minus 3x. And I've got plus 1 minus 5, that's a minus 4. And so I can now think of that one block, I've simplified it. And the block on the right, I've simplified it. So I get a new representation of the same thing. So notice how I have these equations, right? Every time I'm replacing a formula with a simplified version of the formula, I need to say I'm still equal to the original complete block. And now I can simplify again. X squared minus x squared, those cancel. Minus 3x plus 7x gives me 4x. And minus 4 minus 6 gives me minus 10. And so what I've done now is I've taken that original card, f of x plus 1 minus f of x minus 1, and through a series of manipulations, I found an equivalent formula that has the same value, 4x minus 10. So this is how I want to think about equations with algebra. Well, we're also learning about limits, right? Limits, we use them for derivatives. We use them for calculating the value of a function if I filled in a hole. I use limits in lots of different representations. So imagine now that I was assigned this problem. I want to find a derivative using the definition that involves a limit. So I've got f of x is the square root of x, and I want to find f prime of 4, and it's defined by the limit as x goes to 4 of this average rate of change that's f of x minus f of 4 all over x minus 4. That's a card, right? The f prime of 4, if I turn the card over, if I want to know f prime of 4, the back of that card is this limit. And so if I want to find this limit, I need to calculate its value. One of the key things I want you to understand about limits is that there's the value of the card, or the value of the limit. That's the box surrounding the entire thing. It's a value, right? It's f prime of 4. But inside of the limit is the formula I'm working with. So I have a card inside a card. And this is a lot like a function, right? I have f with its input. Well, this is the limit with its input. And this average rate of change is the input to the limit. Well, whenever I'm working with a formula, I'm changing the card inside. I've replaced f of x minus 4, f of x minus f of 4 over x minus 4 with its value. I've turned the f of x card over, right? That's the square root of x. And I've turned the f of 4 card over, and that's the square root of 4. So now, if I want to find the value of this limit, I need to rewrite that formula that's inside the limit. So I'm thinking now about that inside card, and I'm going to do the algebra on the inside. Well, I need to cancel away the x minus 4 in the denominator. And so one way that we do that is through this process called multiplying by a conjugate. I'm going to take that original formula, multiply by 1. So far I haven't changed the value. Those are two sides of the same card. And if I rewrite that 1 as the conjugate over the conjugate, right? Square root of x minus square root of 4, its conjugate is square root of x plus square root of 4. And so I write that on the top and the bottom. And multiplying fractions just means I'm multiplying the numerators and I'm multiplying the denominators. So these are equivalent representations. These are all the different sides of the same card. Well, now, when I think about that numerator, it's a FOIL, right? It's a product of two binomials, and I can multiply it out. First terms, outside terms, inside terms, and last terms. And the square root of x times the square root of x is just x. And the outside term, square root of 4 times square root of x, and the inside terms minus square root of 4 times square root of x, those are going to cancel. And then the last terms, minus square root of 4 times square root of 4, gives me just minus 4. When I simplify that numerator, when I turn the card of the numerator over with simplification, all that's left is x minus 4. And now this card, x minus 4 over x minus 4 times square root of x plus square root of 4, I see I can cancel that x minus 4. But notice that for a formula, this is replacing a whole, right? These functions are not equivalent except where x is not equal to 4. Now, in terms of the limits, what do? They look at the formula to the left and they look at the formula to the right, and they then let x get closer to 4. Well, these two formulas are the same to the left and to the right, so I can change the limit now. So far I've been working on the formula inside, and now I'm going to turn the limit card over, and the limit is going to be replaced by the limit of my new formula. Notice that I still have a limit. I haven't left the question of I need to calculate a limit. The limit of the average rate of change is equal to the limit of this new formula. The way that I get rid of the limit is I use the idea of continuity. Remember, the definition of being continuous is to say the limit of a formula is the same as the value of the formula. So if I think about a formula that's continuous and I have a limit of that formula, then to evaluate that limit, I'm going to replace the limit of the formula with the value of a formula. And notice there's no more limit on this piece. When I use continuity, I'm getting rid of the limit and changing it to a value. So let's go back and think about this problem that we're looking at. When I want to find f prime of 4, it's the limit of this average rate of change. And I replace the average rate of change with the formulas. I rewrite the formula using the conjugate, which we found simplified to x minus 4 all over this x minus 4 times the square root of x plus square root of 4. And I cancel those x minus 4s. Now that was a step where I'm using the properties of limits, because functions can't do this, but limits can. And now, by continuity of this new formula, I can replace the square root of x with the square root of 4. And now, what is square root of 4? It's 2. So I have 1 over 2 plus 2, and the value of this is 1/4. So the front of the card f prime of 4, if I turn the card over enough times, I discover that it's equal to the value of 1/4. So hopefully this has helped you think about when I'm finding limits and I have this limit of a formula, when I'm changing the formula, the limit's still there. When I evaluate the limit using continuity and I replace the x's with the value of 4, I get rid of the limit step, right? I'm done with the limit. All right, well, thank you. I hope this was helpful.